this video, I'm going to explain the methods of calculus used to determine the total displacement, or integral, of our car during a 45-minute long drive. By subtracting the mileage at the end of the trip from the mileage at the beginning, I found the total distance we traveled during that time. This is the number that I had to try to come close to by using calculus. The method I used was Riemann sums. This chart shows how fast we were going every 4 minutes, or 0.067 hours. As you could tell, because only 9 data points were used, this is going to be quite an inaccurate reading compared to the actual mileage. Using Excel, I managed to create 2 different graphs, one showing the left-handed Riemann sums, and the other showing the right. The difference in these 2 graphs is that the left-handed Riemann sums excluded the last set of data points, whereas the right-handed Riemann sums excluded the first set of data points. Here is the graph of the left-handed Riemann sums. As you can see, the x-axis is the time in hours, and the y-axis is this velocity in miles per hour. The same applies for this right-handed Riemann sums graph. And as I said earlier, the first set of data points on this graph was taken away. And the last set of data points on this left-handed Riemann sums graph was taken away also. The reason for taking away these data points was so we can approximate the integral of the space underneath these points, which shows the total displacement of the trip. In this graph, I've connected the points with a line to show that how the area under this line shows how many miles we went. What the Riemann sum does is it takes the whole 40-minute period of time and splits it up into subdivisions. In this case, we took a reading every 4 minutes, which gave us 9 data points. This shows you how the left-hand Riemann sum, shown on the right-hand side of this picture, that the columns intercept the line, the left-hand side of the top of the column, during that time interval. The fact that the only 2 known speeds are the 68 on the top left-hand of the blue column and the 0 on the bottom right-hand of the blue column is what gives us the error, because we don't know any of the velocities in between these 2 points. Here's a comparison of the 2 and how they're different. So now that I've explained what the Riemann sum does and how it works, now I'll show you how I found the mileage. So what I'm doing in this calculation is finding the area of each of these blue columns and adding them up to get the total mileage. The same thing was done here with this right-handed Riemann sums. Lastly, these 2 numbers were averaged together to find the approximate miles traveled. Simply by subtracting the actual mileage and the number we just came up with, we could see the error in our formulas. The easiest way to decrease this error and get a more accurate reading would be to have more subintervals during this 40-minute drive, giving us shorter periods of time with unknown velocities.